We shall now talk about the binary number system, the octal number system, and the hexadecimal number system and try to understand a few basic concepts. The reason computers use binary digits is it greatly simplifies the design of an electronic circuit. If you had a decimal number system, you would have to have 10 different voltage levels, which would make it extremely error prone and difficult to design circuits around them. By having binary number systems, it is really easy, or it is not really easy, it is easy to design a electronic circuit. Now you need to understand a concept called as MSP and LSP. MSP stands for most significant bit, LSP stands for least significant bit. So if you look at this number 11011, this one here before the dot, this one here is known as the least significant bit, and this is known as the most significant bit. You'll know why this is called MSB and why this is called LSB. So let's say we try to represent this particular fellow in this particular table. So if you see, this is before the decimal, this is after the decimal. So before the decimal, if you see, the weight of 1 is 2 raised to 0. The weight of this one is 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, and so on as we keep moving to the left side. And on the right side, it keeps decreasing. 2 raised to 0, 2 raised to minus 1, 2 raised to minus 2, and 2 raised to minus 3. Now, let's look at what are the values of these weights. So 2 raised to 4 is 16, 2 cube is 8, 2 raised to 4 is 2 raised to 2 is 4, 2 raised to 1 is 2, 2 raised to 0 is 1, 2 raised to minus 1 is 0.5, 2 raised to minus 2 is 0.25, 2 raised to minus 3 is 0.125. So now if we have to get the equal or the equivalent decimal value, we have to multiply each of these digits by the values or the weights. So let's see how we do it. So what I am doing is I'm multiplying 1 into 2 raised to 4, which is 1 into 16, 1 into 8, 0 into 4, 1 into 2, 1 into 1, 1 into 0.5, 0 into 0.25, 0, 1 into 0.125. So when we multiply, you will see that 1 into 2 raised to 4 is 16, 8, then this position was 0, 2, 1, 0.5, this position was 0 into 0.25 was 0, and this was 1 into 1.125 was 0.125. Now if you add all of this, you're going to end up getting 27.625. So just be sure you understand how you're converting a binary number into a decimal number by multiplying it with its weights. So if you multiply it with its weights, each individual digit with its exact or corresponding weight, you are going to get the exact value. So this should give you an idea about the weights. So left of the decimal point, the weights start from 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. In decimal number system, it starts from 10 raised to 0, 10 raised to 1, 10 raised to 2, and so on. So I hope you had a decent understanding of the binary number system. Now let's try to understand a little bit about the next important number system, which is going to be used very frequently in the computers you're going to study. The octal number system gets its name because it's got 8 unique digits starting from 0 to 7. There is no 8 in an octal number system. There is only 7. Hence, the base or the radix is 8. In an octal or hexadecimal number system, the advantage why we tend to learn or understand octal and hexadecimal system is a group of binary digits can be represented using just a single octal or hexadecimal number. This will make more clear once we come to take a look at that particular section. So let's try to take this particular octal number. So if you take a look at this octal number 234.56, the weight of 4 is going to be 8 raised to 0, 3 is going to be 8 raised to 1, 2 is going to be 8 raised to 2. The reason you're having weights as powers of 8 is because we are in the octal system. So this number in the octal system is going to be converted to a decimal number. 5 is 8 raised to minus 1, 6 is 8 raised to minus 2. Now if you see the values for this weight, 8 square 64, 8 raised to 1 is 8. 8 raised to the power of 0 is 1. 8 raised to minus 1 is 1 upon 8 is 0.125. 1 upon 64 is 0.03125. Now it is quite easy. If I multiply 2 into 8 square or 2 into 64, I am going to get the sum of this number in decimal. 2 into 8 square plus 3 into 8 raised to 1, 4 into 8 raised to 0, 5 into 8 raised to minus 1 plus 6 into 8 raised to minus 2. That particular value ends up becoming equal to 2 into 64, 3 into 8, 4 into 1, 5 into 0.125, 6 into 0.03125. Now you get this particular, after you resolve this, multiply this, you end up getting this. Once you add this particular stuff, you are going to get the number 156.71875. You can verify this on your own and give it a check. Now let's take a look at the hexadecimal number system. Hexadecimal, along with octal and binary, is essential to have a good conceptual clarity when you're working on computers. So just be aware that you need to have decent understanding of the hexadecimal number system. Now in hexadecimal number system, hex means 16. You got 16 unique digits starting from 0 and you have the letters A, B, C, D, E and F. The digit A represents 10 in decimal, B represents 11 in decimal, C represents 12 in decimal, and so on. F represents 15 in decimal. That is the equivalent decimal values. Now let's try to understand the hexadecimal number system by trying to convert this 5AF point D to the base 16 or the hexadecimal system to a decimal number system. So what will be the weight of F? It will be 16 raised to 0. A will be 16 raised to 1. 5 will be 16 raised to 2. Why are these weights? Because they are to the base 16. So here if you see, let's take a look at the number. F is 16 raised to 0 weight. A is 16 raised to 1. 5 is 16 raised to 2. And D is after the decimal place. So its weight is 16 raised to minus 1. Now what are the values of these weights? 16 square is 256. 16 raised to 1 is 16. 16 raised to 0 is 1. 1 upon 16 is 0.0625. Now we need to multiply all these fellows together and add them up. So let's see how that is done. So it is 5 into 16 square, which is 256. A into 16. A is nothing but it is 10. So it is 10 into 16. F is 15. So 15 into 1. Then D is 13. 13 into 16 raised to minus 1. So let's see what are the values. So here you have 256 into 5, 160. 16 into 10, 160. Plus 15 into 1 plus 0.8125. Once you add all of this, this is going to be the result. 1455.8125. So this should give you an idea about what is hexadecimal number system and how do you convert from hexadecimal number system to a decimal number system by using the weights and multiplying it by the digits.